Hello there, integrated science students, and welcome to our first video lesson for Unit 3, Earth's Materials. This video lesson is going to cover the material from section 26.1 in your textbook, starting on page 808, and it's going to be everything about minerals, and we're going to have 5 major little topics here that we're going to talk about with minerals. So more than we have in the past videos, but each topic doesn't contain a ton of information. Okay, we're just going to highlight the major parts and use about 2 class periods to kind of cover each one of these 5 major topics about minerals. So the first topic that we're going to look at is the actual definition of a mineral. So what makes a mineral a mineral? We're going to talk about the chemical composition and some of the physical properties or physical traits that minerals have. We're going to look at mineral identification. Okay, so that's going to be the second major topic for our video. We're going to talk about the items that geologists use, the traits, the criteria for actually identifying a mineral. We're going to get into mineral formation, so talk about 3 major ways that minerals are formed. We're going to look at the groups of minerals, mainly 2 groups that we're going to analyze, and then we're going to get into the uses. All right, so some common everyday uses of minerals and some really fantastic kind of out there uses for some minerals. All right, so those are the 5 video topics that we're looking at. Let's get underway. The definition for a mineral, simply put, is an inorganic, naturally occurring solid in crystalline form. Inorganic meaning that it's not living, nor does it necessarily provide the energy needed to fuel living things. Okay, so it's inorganic, it is naturally occurring, and we're going to get into the formation here in a little bit, and it's a solid that is in crystalline shape. Now the crystalline thing is going to come in here in a little bit, but we've got to think that these minerals are composed of elements. Okay, those elements that we find on the periodic table of elements here. Everything, all matter in this universe is made up of those elements on the periodic table, as is every single piece of material that's on this planet that is naturally occurring. Okay, so not your man-made synthetic stuff, but the naturally occurring materials. Everything's made up of those elements, and those elements want to bond and combine with each other. And when they bond and combine with each other, they form materials, molecules and compounds, and sometimes these compounds and molecules can make minerals. Some of Earth's materials that are generated by those internal and some external processes. Now the crystalline shape gets in to the atoms and the atomic arrangement of the atoms and elements that are making up the mineral. But each mineral has a distinct chemical composition. Each one has a distinct chemical formula. It's a certain amount of these elements with a certain amount of these elements. And that gives it its distinct, specific physical properties. So minerals are naturally occurring solid, inorganic substances with crystalline form, and they have a distinct chemical composition, chemical formula. They've got this many of this element, this many of this element, and it's that chemical formula that gives it several distinct physical properties. That's what a mineral is. So, to piggyback right off of our definition of a mineral and solidifying that minerals themselves, the variations of minerals, the amount of minerals, all depends upon their distinct chemical compositions, so the elements that make them up, and the physical properties that are then on display because of that distinct chemical composition. We get into mineral identification. Okay, so the actual physical properties that are created because of that specific chemical composition, it's a lot of those physical properties that we are examining in order to identify a mineral. Physical properties being luster, streak, atomic arrangement, cleavage, fracture, and hardness. With these 6 categories of mineral properties, we can identify minerals from one another, because sometimes minerals can look really similar and share several of the same physical and sometimes chemical properties. So we have to use a wide array of traits in order to identify and differentiate them from one another. Luster is a pretty popular one, and luster is basically the way that light reflects or shines off of the surface of the mineral. We typically say there's 2 types of luster, metallic and non-metallic. Although there can be some that again are kind of confusing, almost kind of in-betweeners. Sometimes they have glassy appearances, and we call that vitreous. All right. Sometimes they may have an earthy appearance, and we'll call that dull, or an earth tone, an earthiness. Streak is the actual color of the mineral in powder form. It's more reliable than color because simple impurities in the chemical composition of a mineral can throw the color off gigantically. And then all of a sudden we're completely misidentifying it. So color itself of a mineral is not a really great indicator, although it's pretty good for some minerals. But the streak color, the actual color when you take that mineral and actually get it to leave a powdered residue, that powdered residue's color is the streak color, and it's another great identifier from mineral to mineral to mineral. Atomic arrangement kind of goes hand in hand with crystal shape or crystalline form. The way that the atoms arrange themselves, or the elements, the atoms that make up the elements, arrange themselves after they've been solidified can give that mineral a distinct shape. Okay? It's the geometry behind it. It's the geometry behind the chemistry of the chemical composition. We don't need to go into all of that, but know that the way that the atoms arrange themselves after they've combined with other like and different elements, atoms, okay, can create specific shapes, and the actual larger solid chunk of mineral specimen can display various shapes because of the atomic arrangement and the crystal shape that is created because of the bonding. There are two categories that assist us in mineral identification, and it deals with the breaking of a mineral. If you break a mineral and it breaks off into sheets or clearly defined planes, we call that cleavage. So if we've got smooth, parallel, or even perpendicular and parallel planes that are created because of the breaking of a mineral, we call that cleavage. And there could be a wide array of cleavages that might be created from various minerals breaking. It's one way to identify them from one another. The other method of breakage that there is that helps us identify minerals is fracture. And that's when you break the mineral and there are no smooth sides that are a result of the breakage. It's very irregular, it's very erratic, and it has no rhyme or reason. That is fracture, and it's another telltale sign that we use to identify minerals from one another. The last of the 6 categories that we're going to use to identify minerals is hardness. And hardness is basically a mineral's ability to be scratched or not be scratched or to do the scratching. Okay? So the physical property that measures a mineral's resistance to scratching is called hardness. Now I said that it could be its ability to scratch or to get scratched because we compare and contrast these minerals to one another in terms of hardness by just testing them in terms of hardness against one another. Okay? There are some minerals that you can take and actually scratch another mineral. You know it's harder than the mineral that was just scratched. There's a scale that we're going to use, and it's called Mohs hardness scale. It goes from 1 to 10. You can place things in between the whole numbers of 1, 2, 2, 3, 3, 4, etc. Okay? But we'll get familiar with that, and we'll get to understanding the very, very soft minerals and the very, very hard minerals, and we'll get to comparing and contrasting them against some other standards that we use to establish various levels of hardness. So hardness, mineral's ability or resistance to scratching. Okay, so that does it for mineral identification. Let's move on to our third video topic, and that deals with the formation of minerals. Now from our definition, we talked about how a mineral is an inorganic, naturally occurring solid with crystal shape, crystalline form. So we got 3 types of formation, and every single one deals with the getting to of a crystal shape. So like the point where finally we've got crystallization taking place. The first one is minerals forming from hot water. Anytime you've got water and it's super hot, a lot of other substances can dissolve inside of it. But eventually that hot water is going to cool. And as it cools, the atoms and ions and the materials inside that water start to slow down. And when they slow down, they start to bond with one another. Once they bond, that's when we start to get some of the crystals that form, and voila, we have ourselves a mineral. The actual forming of a solid from some type of liquid or some type of fluid is called a precipitate. So minerals can precipitate out of a liquid solution, most notably hot water once it cools. The other type of formation is just the cooling of magma. So again, the particles, the atoms, the elements that are present in that magma start to slow down. As they start to slow down, they start to form crystals, and those crystals grow, and give us that mineral. It's a cooling, it's a crystallization process. Minerals can also form from the cooling of magma. The last formation process kind of ties into the first one we talked about, but it's not the cooling of water and a precipitate forming from inside of the liquid, but it's actually the removal of water completely. It's evaporation. So you can have things that kind of precipitate out of a liquid solution because the liquid just goes away. Okay? If you were to boil some water on the stove and it had salt inside of it, or just any water inside of a pan, a dark surface, if you will, and you let that water completely evaporate, you're going to see a thin film or residue inside of that. Those are actual mineral crystals there. Those are the minerals that are present within your tap water. So minerals can also be formed just by the fact of evaporation, just by that nice little process of evaporation. Liquids eventually becoming gaseous and floating around the atmosphere, leaving these solid, inorganic, naturally forming, crystalline-shaped minerals behind. Okay, the last two video topics we have are pretty short and sweet. When we get into groups of minerals, we're pretty much talking silicates versus non-silicates. Silicates being minerals that contain silicon. Okay, your silicate minerals, the most notable one is going to be quartz. We've also got a couple like pyrazine, amphibolite, and mica. We're going to examine every single one of those, so don't freak out if the name seems super strange. Okay, but any type of mineral that contains silicon, all right, element S lowercase I, is considered a silicate. We get a lot of silicates inside of Earth's crust. The continental crust is just exploding with silicate minerals, and there are also plenty that are found in the oceanic crust. Okay, we've also got one that's known as feldspar. Okay, and if you've ever seen granite countertops, granite's a rock we're going to look at in this unit. Granite's composed of feldspar, quartz, and pyrazine. Okay, so three major silicate minerals. Silicates are typically very strong minerals that also form very strong rock. Okay, so the first group, the silicates, minerals that contain silicon. To be super technical, scientists went ahead and they called this other major group of minerals non-silicates. So minerals that don't contain silicon. We have a few of these groups, though, subgroups of the non-silicates. Carbonates, so minerals that are very heavy in carbon. Halides, minerals that are very saturated in sodium. Okay, oxides, sulfides, sulfates, and other native elements. With these non-silicate materials, we're going to see, or non-silicate minerals, we're going to see a lot of your metal ores. Okay, your metal ores. So some of those elements on the periodic table that exist kind of towards the left side. Okay, towards the left side or throughout the middle with the transition metals. But we've got silicates, non-silicates. Silicates contain silicon, non-silicates do not. And we're going to see a lot of salt. Okay, we're going to see a lot of carbon-based minerals. And we're going to see some minerals that are very heavy in sulfur. And we're going to see minerals that are just metallic, I guess. Very metallic and metal-like in nature. Last but not least, the uses of minerals. I'm not going to go into this really at all because this is what we're going to really spend quite a bit of class time on our second mineral day covering, the different ways that we can use minerals. That does it for this video. Hopefully you feel pretty comfortable about the 5 major topics that we are covering with this video lesson. That's all covered in section 26.1 in your textbook. That's the general definition of a mineral, how we identify minerals with those 6 categories, those 6 pieces of criteria, the actual formation of minerals, the 2 major groups that we examine when we're talking about minerals, and finally some basic everyday uses of minerals. Get this bad boy worked on. This is the directed reading guide that goes along with each one of the sections from the reading of the textbook, pages 808 through 841, something along those lines. Read up, finish this bad boy, and shameless little plug here for the unit vocabulary that can be found on the Quizlet website. Everybody's got this piece of paper. Look over this stuff. Start practicing that vocabulary now. Okay? See you guys in class. We're going to talk everything minerals. Adios!